Started, how long do we have?
We got 30 minutes. We might end up having to go over because we're starting late, so I do apologize for that.
Okay, not a problem. Okay, great. So we're going to talk about cloud native open data, which could be used for monitoring applications or other activities. But we thought it would be an interesting topic for this group because there are growing public data sets available in the cloud. And I know a lot of attention is focused in this conference on the collection of local data and kind of bottom up. But there may be opportunities to combine that bottom up approach with a top down approach and kind of increase the value of your GIS data sets. So with me today is AJ Wortley. I think many of you know us from WLAAs and other things in the past. Currently, we're representing Syncarto here. Syncarto is a cloud native mapping platform in which you could actually utilize some of these data sets. So with that, then we'll move on to, sorry, I need to get my screen moving here. Okay, so one thing that's happening in the industry is that larger and larger data sets are being collected, and these data sets are starting to exceed what you can download and store on your computer for many uses. So this includes aerial imagery like NAPE, which is we calculated to be approximately 97 terabytes in size at this time. And Landsat and Sentinel, which are together form a database of many petabytes of data. And these data sets are growing every year. So as new flights are done for NAPE, or as satellites transverse the Earth several times a week, and in some cases now the private satellite companies are collecting data on a daily basis. These data sets are growing exponentially through time. So with data this large, it makes sense to store it in a place that has equally large storage capacity, and the major cloud vendors have that capability, and they also, because of the scale, are able to store that data at a relatively low cost. So there's another number of things that go into being able to take advantage of that data when it's sitting there in the cloud. And so some of these things are storing the data once in one place and then not storing copies of it, because as you can imagine, if the data set's that large, then it's expensive just to store one copy. And so making additional copies of that only increases the cost for everyone. And so if you're going to do that, then you want to be able to make it accessible in that one location to as many people as possible. And one of the things you want to make it accessible to is the ability to process it as close as possible to where it's being stored. You also want it to be compatible with common software packages. So if it only works in one system, it's not going to be that accessible to as many people as it could be. So with that, you want to follow certain standards so that there is interoperability between software packages. And it's also important to store it in a format that's ready for analysis. So this can mean many things depending on what the application is, but in general, the idea is that someone could pick up those pixels, just the pixels they need, and start doing operations on them in their software. You also, in order to find this data, then there also needs to be searchable catalogs. that enables somebody to discover the data and to find just the pieces of the data that they need relatively quickly and seamlessly. And then another concept here is that you only want to take data out of that storage and bring it somewhere else that's just the data that you need, so that you're not taking down whole tile sets, for instance, if you really only want a small section of 1/4 quad of data to process. AJ, anything to add here?
Nope, I think you've hit all the high points.
All right, so there's a number of enabling technologies that are effectively standards that are coming out of the federal government and the folks who are trying to deal with these very large data sets, including some of the private sector satellite companies, because like the Maxars and the planets have the same problem that the federal government does in dealing with their large volume of data. So these are cloud optimized Geotiffs. So basically it's a way to organize your Geotiff so that you can pull out pieces of it directly from the full resolution version. It's internally tiled so that you can find those pieces quickly and easily, and it already contains overviews so that if you're zoomed out, you can also extract those overviews without downloading the whole file. Another enabling technology is spatio-temporal asset catalogs called STAC. These are lightweight metadata, and it's basically composed of JSON files for each item, and then these files are referenced in other JSON files called catalogs. And those files can then be ingested into a standards-based API, such as the STAC API implementation. And what this does is it allows other software to interact quickly with those data sets. So typically, STAC API is backed by a database, either Postgres or perhaps Elasticsearch, and that makes those files easily queried on the fly. So then those can support things like tiling services. So for instance, in Sycardo, our tiling service is able to tile native resolution geotiffs on the fly because it can know about which of those geotiffs are intersecting the area of interest via the STAC catalog. And then the tiling service can go make smart minimal requests to S3 API to only extract the bytes that are necessary to render those tiles. And I've also threw in here CDN, which I should explain is a content delivery network. So it's the same kind of technology that's used to deliver websites faster. But usually those supply caching and then caching at edge locations in the cloud so that there's less latency between the time you make your request and the time you get an asset. AJ, I'm going to keep going. You feel free to jump in if you have commentary.
Sure.
All right. So just to go into a little bit more detail on the cloud optimized Geotiff. I know I've done this probably for the last couple of years, but I'll just make it quick. So the typical TIFF might be arranged line by line, but in a cloud optimized Geotiff, the byte arrangement is tiled so that you can make range requests to the file and just get out the section that you might be zoomed into. There's also overviews, and you can make similar range requests to the overviews. The other technology to dive into a little bit is the spatial-temporal asset catalog. Again, it's composed of items, and those items make up a catalog. It also has the concept of a collection, and it's at the collection level that many things like licenses and extents and keywords and those kind of things are stored. And one of the things that we're doing with the community is working on a crosswalk between FGDC metadata, for instance, and what's stored in the spatio-temporal asset catalogs. It's not necessarily the case that the STAC would replace something like FGDC metadata. It's a STAC catalog is mostly a summary of what's inside of Geotiff headers. But it benefits from some of the information that's in the FGDC metadata in terms of keywords or licensing or links to other data. Another thing that's not listed here, but so the STAC catalog, an actual item would contain a list of assets, and those assets could be the imagery, or in some cases it could be the metadata files. So, for instance, if you were to look at the STAC item for a NAPE image, it would list the imagery, which in the case of NAPE might include the source imagery, it might include the analytic imagery, and it might include the visualization imagery, because right now on AWS, I believe ESRI is curating three different versions of it. One is the source, one is the analytic data, and one is the visualization. And they're used for different purposes. And in fact, they're in different file formats. So it's not completely necessary that these things be stored in cloud optimized Geotiffs. It's just that's one optimal way of doing it. And for instance, Esri has the MRF file format that the NAPE analytic data is stored in. And then the original data is in, I believe is in Geotiffs as well, but not cloud optimized versions of them. Whereas the visualization is in cloud optimized and can be tiled on the fly. So the large cloud vendors have these programs where people can put public sector data up onto the cloud, and basically if they agree to make the data available to the public for free, then the vendor like AWS offers credits for the storage for some period of time, and so they've been promoting that program for many years. I'm sure you've heard Mark Corver talk about it here at WLAA even several years ago. But I would say that one of the reasons we wanted to give a talk on this topic this year is it seems like there's a lot of momentum and new things are being released, just within the past year even. So you can go to AWS's website, you can go to their list of data sets, and you can look at all the data sets that are available, and there's even links to example applications of the data. Google Earth Engine has a similar program. They've been collecting public data sets for a long time on their own. And they make the data available on the fly in their Google Earth Engine product, which is proprietary, but I believe that many of their data sets are actually accessible outside of Google Earth Engine. And the spatial-temporal asset catalog community has also put up this site called STAC Index, and it contains a database of publicly available STAC catalogs and publicly available STAC compatible APIs. And these references will be on the final slide. Excuse me. Okay, so what kind of data can you actually get from these programs? Well, there's MODIS. So MODIS is a daily return satellite image system. There's actually a couple of different satellites, and Aqua and Terra, and they produce multi-spectral data, both in the visible and infrared. Let's see, then there's kind of getting a little bit higher resolution. There's the Landsat data, which has a 16-day return time. Currently, Landsat 8 is available in the public data program, but I think there is some movement to provide some of the rest of the Landsat catalog. Well, to migrate that into more publicly available formats. I don't know exactly what the plans are there, but I believe even the Eros data center, even though you have to still download it from the Eros data center, the earlier versions of Landsat are available, have been cataloged as STAC items. Excuse me. And then Sentinel-2 is a satellite program run by the European Space Agency. Sentinel-2 is kind of their equivalent of Landsat. I believe there's a 5-day return time on Sentinel now. It's slightly higher resolution than Landsat. It is also multi-spectral, so it has both visible and near-infrared bands. I'm not sure that Sentinel has a thermal band like Landsat does, but the Sentinel program also encompasses Sentinel-3, and I believe there's a Sentinel-4, Sentinel-5, which are more climate-related satellites. Those are also becoming available as public data. And one that probably doesn't get as much attention or hasn't had as much attention in the past, but I think is getting more attention these days because there are private satellite companies that are exploring radar satellites. So Sentinel-1 is a synthetic aperture radar satellite system that can, I think there are more and more tools to process the Sentinel-1 data into kind of the equivalent of imagery that you could then fuse into your other data analysis projects. And then the private sector is also starting to generate daily return time, higher resolution synthetic aperture radar data. So watch out for that, because one of the value of synthetic aperture radar is it's all weather, and it can see through clouds. So important for monitoring activities. Another set of satellite data that you may or may not be aware of is the China-Brazil remote sensing system. They produce some medium resolution multispectral data and panchromatic data. It's also available in AWS's open data program right now and cataloged in, I believe it's available in COG format and cataloged with STAC catalogs. Another data set that is maybe important at the local level is the NAPE data set. NAPE is available in the AWS Open Data Program, and as I mentioned before, it's available in 3 flavors: the analytic, the source data, and the visualization data. And we have an example in Sicardo of being able to reach into that data set and pull out tiles on the fly and present that to the user. Yet another kind of data that's available in the open data program, and this was just announced within the past few months, is the USGS 3DEP program LiDAR data. So what I'm showing on the screen right now is actually a chunk of LiDAR data displayed in the USGS's Entwine viewer directly off of that 3-depth open data set. And I believe this chunk is from Langley County, Wisconsin. So we wanted to take a few slides and say, okay, so you have all this data available. Much of it is at kind of a different resolution than the counties are used to working at. So what could this data be used for? Here's an example of data fusion with multiple data sets. Some of these, like the nighttime lights and the land surface temperature, would be available in the open data program. And the land cover, I'm guessing the land cover they're using perhaps comes from WisClan, but it could also come from it could be generated out of a time series of Landsat data, for instance. And then they also have a series of wildlife cameras placed across Wisconsin. And they're combining all this information together to model the ecosystem of the wildlife and their habitat. Is that, AJ, do you have?
Fair description? Yeah. This is coming out of Forest and Wildlife Ecology at UW-Madison, along with their collaborators, with Phil Townsend leading this study. But this is just one example, I think, of the state and regional applications where we know remote sensing is being actively used and more thoroughly explored. We also are aware of some various coastal management applications, and certainly both public and private sector agricultural monitoring, as well as the DNR's collaboration both with and without the UW on lake water quality and clarity. So we just wanted to showcase a few of these examples, but I think these are starting to build a bridge to where local and regional organizations can start to think about how they might be able to incorporate some of these other sources with a less onerous way in order to explore some new types of applications at the local level.
In another way that we think that data fusion can be used from multi-resolution data is, for instance, in segmentation. So, for various reasons, you want to collect your local data, perhaps your local imagery is leaf off, but then when it comes time to segment between impervious surfaces and vegetative surfaces, then having some information on what's happening during the growing season of the plants and the phenology of the plants can be useful in your segmentation process. Also, the segmenting rooftops and trees and things like that, it could be useful to incorporate LiDAR with your imagery data sets. So, so in terms of pulling in some information on the vegetation, there's a couple ways you can do that. You can pull it in from the NAPE data set, which tends to be leaf on, or you can pull it in from a time series of one of the satellites, and perhaps extract some phenological information, as well as the location, and then merge those two data sets together, perhaps merge it with LiDAR, and then produce a better segmentation of your land cover at the local level. I'm going to play a short video. And so one of the ways in which having the spatial and temporal catalog of your satellite images or these large image data sets is helpful is that it can allow you to process a time series of information, and then you could extract that time series onto, say, your building footprints or your property footprints or other such things as that. So I'll just show a brief example of processing NDVI out of the Sentinel data set. I think this is 2020 data over the summer in a agricultural area in Wisconsin. And so you can see some of the fact that the farm fields are getting greener through time, and then towards the end of the season, then they get harvested. So simple example, it's kind of the hello world of what you can do with the satellite data, but I wanted to kind of highlight the ability to extract time series information relatively quickly using these data sets and cloud native technology. And then lastly, sorry, we're not on the next slide. Okay, one of the things that isn't in the open data program right now, but we would like to make more accessible going forward is a lot of the NRCS soil information and some of the other data sets that are collected that are not just imagery, right? So the NRCS has the Surgo database, which is a very extensive database of soil information, and not just the raw soil information, but they've actually make interpretations of that soil data available. And so, one of the things we've been trying to work on in Sicardo is how do we make data more accessible and more easy for a human or a busy technical user or even less technical users to access. And so one of the ways we've done this is to try to combine natural language processing with the ability to query web services and these type of libraries. And so here's an example of being able to just say something like, tell me about organic matter depletion, and then have the computer respond to that, and then display that, go out to the NRCS, handle all of the query that has to be built to do that, and then return that data, to the user's interface. So, this is something that we hope to do in the future in order to make these large image data sets more accessible, and then to go beyond image data sets and bring other databases to be more accessible to people, whether that's through public data or helping people to share their private data as well. AJ, final thoughts?
I guess I'd just say this is just the beginning. We're talking about large volumes of data and emerging standards for kind of cloud native storage and access capability, but shortly behind are cloud repositories of commonly used analysis type algorithms, and being able to implement those algorithms against the cloud native services and simply receive the final result at your end client. And so we're looking forward to what's coming next.
Great. And with that, we have the references that we mentioned earlier on this slide, and we have our contact information. So if you'd like to know more about what we're doing, or we can somehow help you get access to public data in the cloud, we'd be happy to do that. If you have any questions, I think we could take a few questions now.
Yeah, we've got a couple minutes to let you guys go a little long here, because I know we started late.
Let's see, is there, trying to find the chat in case people are asking in the chat.
gotten a few personal chats, but I don't see any public questions right now. So.
Okay.
Final presentation of the day. I guess we just blew them away. Everybody's ready for lunch.
Yeah, everybody's on mute, but it is an impressive number of people here for the last talk of the day.
Well, we can go ahead and wrap it up, and just want to thank you, Woody and AJ, for a great presentation, and thanks everybody. I also want to thank from this entire track sessions our speakers today. That was Emily and Jay, Larry, Gail, and of course Woody and AJ. So that should wrap us all up. So thanks again, and I hope to see everybody over at the lunch presentation.
All right, thank you.
Thanks.